right? This is our second section in Module 11. Remember this chapter, we're pretty much talking about gravity. It is one of the four forces of nature. First one is gravity, second one is electromagnetic, third one is weak, fourth one is strong. Now, circular motion, you might not think of that as being related to gravity, but it really is, okay? So, gravitational force, not only does it pull things toward the earth, that's usually what we think of, gravity, it pulls us to the earth. Gravitational force is also responsible for our planets and satellites being in orbit. So a satellite, thinking about like the moon is in orbit around the earth. It is Earth's gravity that is pulling it toward the earth, while its velocity is moving it away from the earth, that together those make circular motion. Okay, so that force, that pulling in toward you force, is called centripetal force, right? It is perpendicular to the velocity. So I want you to think about a ball rolling across the table. Okay, it has a velocity in a certain direction. If we could force that ball with a force that is perpendicular to its velocity, then that ball is going to end up going in a circle. So if you think about a ball rolling, if it was attached to a string, so if we have a ball and it's rolling and it's attached to the string, so our ball's going this way. But if we could attach it to a string, that ball is going to keep going in a circle, right? Is because the string is providing centripetal force that pulls it. So the ball wants to keep going straight. So if that string were to break, that ball would keep going off straight. Okay. So centripetal force is a force that causes the object to go around or revolve around a center point in the circle, is the centripetal force. So if we have a toy airplane, like on a mobile that like a baby would have where it's spinning around, and is attached to a string, when he goes, its plane's velocity is to go off flying straight. It's that centripetal force that is pulling it towards the center, which is going to cause it to go into a circle. So if you'll remember, acceleration is anytime you speed up, slow down, or change directions, right? If an object is moving in a circle, it is constantly changing direction, so we would say it is accelerating. So it's constantly accelerating. Perhaps its speed isn't changing, but it is accelerating because its direction is changing, and that is what is important, is acceleration is a change in velocity. So we would call this centripetal acceleration. If you're changing directions only because you're flying in a circle, it's centripetal acceleration. Right, here's a few principles for centripetal force to keep in mind. You'll need to be able to tell me these back, or at least use them in examples. All right, the first one is that if anything is moving in a circle, it has to be having centripetal force. There has to be something that is pulling it towards the center to cause it to be in a circle. The second one is that if you have a large centripetal force, the object is going to be traveling faster. So if you have a specific size of circle, so if you have a ball on a string and you're holding it at the end of the string, and so the circle you're going to make is a certain size because that is the radius that you have for the string, then if you want that ball to move faster, you're going to have to apply a greater centripetal force. So big force equals faster movement if you have a set size, all right, of circle. Now, if you have a set speed that you're wanting to go at, then, so let's say you have a metronome type of beep, 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 where you're spinning it. If you're wanting a large centripetal force, it's going to make a very small circle. Okay, so if you're doing it at a certain speed, if you have a large force, you're going to have a small circle. If you can adjust the radius of your circle there. So for a given circle size, a large force is fast speed. For a set speed size, then a large force is going to be a small circle. Now, there's another feeling I want you to feel, I want you to think about anytime you've been where you are rotating around in a circle. All right, so think of like on a roller coaster or out on that green spinning around thing that's on our playground. So what is the force that you feel when you're doing it? Do you feel the bar pulling you to the center? Mainly what we usually feel is we feel what seems like a force is pushing us away, right? So when I'm telling you centripetal force is pulling you to the center, centripetal force is a real force. Okay, that's what gravity does for us on our planet. That force where you feel like you're being pushed back, like on a merry-go-round, you have to hold on not to fly off backward, right? That's centrifugal force, and it is fictional. There's not really a force there that is pulling you out. It just feels like there is one, almost to the point where you would bet that there is one, but I'm telling you there's not one. Centrifugal force is fictional. So the way you can remember which one is fictional and which one is not is this F in the center. Centrifugal is fictional. Okay, it's fake. Centripetal is real. There's a quiz today. Go ahead and click on the link and take the quiz. I'll see you in class.